Good morning, everyone. So, in last class, we have discussed about chemical properties of carboxylic acids, and we are now we are going to discuss about chemical properties of acid derivatives. Particularly, we say one is hydrolysis. So, particularly hydrolysis. Okay, and then we have ammonolysis. Ammono Ammonolysis. Okay, so ammonolysis only for preparation of amides. We will discuss only ammonolysis for the preparation of amide. But whereas we will discuss about hydrolysis reactions of all acid derivatives. So what are acid derivatives? So these are the acid derivatives. So this is acyl halide, and next one is amide. So what is the general function formula of amide? R C double bond O NH2, and next anhydride. So what is anhydride? So this is anhydride R C double bond O O C double bond O R. This is anhydride. And next one is sorry anhydride, then ester. So here I supposed to write ester and followed by carboxylic acid. This is ester, and this is already we have extensively studied about this functional group, that is carboxylic acid. And next and last one is acyl halide. So acyl halide means R C double bond O X. Okay, so this OH group of carboxylic acid, here that is replaced with OR, here that is replaced with NH2, here that is replaced with uh, acetate, that is RC double carboxylate, and here with halogen. So these are known as derivatives of carboxylic acid. Okay, so this is acid halide, this is anhydride, this is amide, this is ester. Okay, so now all these undergo nucleophilic substitution reactions. All these undergo which reactions? Nucleophilic substitution reaction. So what is nucleophilic substitution reaction? So if you look at amide, so here outgoing group is NH2. In case of ester, outgoing group is OR. And in case of carboxylic acid, outgoing group is OH. In case of anhydride, the outgoing group is ester. And in case of SN, outgoing group is halide, X minus. So these group will be replaced with a nucleophile. So that's why such reactions in which one nucleophile is replaced with another nucleophile, so those are known as nucleophilic substitution. So in nucleophilic substitution, so this nucleophile is known as incoming nucleophile, and whereas all these are known as outgoing nucleophiles. Outgoing. So they are going out from this function. Okay. So next, let's see the reactivity. So which nucleophile are which acid derivative is more reactive towards nucleophilic substitution reactions? Towards which reactions? Nucleophilic substitution reaction. Okay, let's see. So from here to NH2 to Sl, CHOL, so that is Sl halide. So if it is shown with X, then it is known as Sl halide. But here he is shown as Cl, and that's why it is known as acid chloride. So from here to here, so this one is indicating what? Increasing order of reactivity. So that means out of all these, so which is more reactive? Acid halides or acid chlorides are more reactive. So that means here, if you look at the tendency of outgoing group, so this X minus or the outgoing group is X minus, that is more, it has good leaving group character, then this acetate, then OH, then R and NH2. So this is the order of reactivity of acid derivatives towards the nucleophilic reaction, nucleophilic substitution reactions. Okay, look at this one more. So here see, this is acid halide or acid chloride, this is ester, this is anhydride, this is ester, and this is amide. All these are what? Acid derivatives. If upon hydrolysis of all these, we will get one and only product, that is carboxylic acid. Okay, if look at the reactivity. So reactivity from amide to ester increases, ester to anhydride increases, and from anhydride to acyl halide highest, more increase. So the order of reactivity, how we can conclude? So which is more reactive? So acid halides, so general formula of acid halide is R C double bond OX. It is more reactive than anhydride. So this is OCOR. So then ester C double bond OR, then carboxylic acid, and least reactive is amide. So why it is least reactive? Why? Because it has lone pair of electrons, and these lone pair of electrons readily participates in resonance. So that's why. So this bond, that single bond will get double bond character. If you write the resonance, it will get the double bond character. So due to that, it is less reactive. Okay. So now let's see the hydrolysis reactions of esters. Already we have discussed about the hydrolysis reaction of esters uh, in the uh, in the preparation of carboxylic acids. Okay, so we can prepare carboxylic acid by hydrolyzing any of these acid derivatives, any of these acid derivatives. Okay, so first one is ester hydrolysis. It is very important. Okay, we can expect in the examination also. The ester hydrolysis can be done in presence of acid as well as in presence of base. So ester hydrolysis in presence of acid as well as in base. Okay, let's see the first, amide hydrolysis. Okay, so this is amide hydrolysis. Okay, so this is so here see these amides are again three types. So primary amides, secondary amides, and tertiary amides. So generally see, okay, so this is R C double bond O NH2. This is amide, and this is N substituted N alkyl amide. This is N R comma R dialkyl amide. So we have three different types of amides. So this is amide, this is amide, and this is N substituted amine. This is disubstituted N disubstituted amides. Okay, so here he has taken disubstituted amides and hydrolysis of amides. So okay, so now why we are heating? So if you want to hydrolyze acid halide, if you want to hydrolyze acid halide, so or acid chloride, so we don't require any catalyst, that is maybe acid, or we don't require the presence of acid or base or even heating. Why? Because so acid halide is more reactive, but whereas this amide is least reactive, so that's why it is reluctant to undergo the hydrolysis reactions. So hence we require to force to undergo hydrolysis reaction. So in that process, what we do, so how we force? So by means of heating. So when we heat, what happens? So this will be forced to undergo hydrolysis to result our desired product, that is what, carboxylic acid. And this is irreversible reaction. Why? Because it is a bulky. Why? Because nitrogen has two alkyl substitutions, so that's why it doesn't again, though it has two lone pair of electrons, it do not participate in nucleophilic substitution reaction due to steric hindrance. So here already we have one alkyl group, so these two alkyl groups will be subjected to reversion. So that's why it doesn't undergo any reverse reaction or backward reaction. So that's why we have taken disubstituted and disubstituted amides for this hydrolysis of amides. Let's see the mechanism. So let's see. So it undergo here in this mechanism. If you look at the mechanism, overall mechanism, here we specified 6 steps. So this is first step. So in presence of acid. So here see, here he used a medium. That is what, in presence of acid. So here he used a medium in presence of acid. Why? Because so here he has taken only amide. Nitrogen is not substituted with any alkyl part. So without substituted amide he has taken. So that's why he is maintaining acidic medium. Why? Because the acidic medium will provide only forward direction of reaction. So if he, without acidic medium, what happens again? The reverse reaction may take place. Whatever product formed here, that will undergo the nucleophilic substitution reaction with resulted ammonium ion. So thereby again we get what? So instead of ammonium ion, here we get ammonia. So again that ammonia will participate in nucleophilic substitution reaction and to result our starting material. So to avoid that, here we are maintaining what? Acidic medium. Okay. So mechanism of acid catalyzed hydrolysis of amides. So acid catalyzed hydrolysis of amide. So okay, so if you have n disubstituted amide, in this case, you don't require any catalyst. Okay, why? Because it is less reactive. Why? Due to steric hindrance. Okay, so let's see the first step. So what is this reaction? The mechanism of acid catalyzed hydrolysis of amide. So in first reaction, so this acid will donate its H plus. So what is the role of acid? What is the role of acid? Acid donates H plus ion. So this donated H plus ion directly are readily attached to the oxygen. So thereby it creates positive charge on oxygen. So this is known as oxonium ion. It is highly unstable and it pulls pi electron towards it. So thereby this carbonyl carbon becomes more electron deficient. In next step, what happens? The water oxygen of water will attack on carbonyl carbon. So then the complete shifting of this pi bond is taken place. So that's why. So here see what is the hybridization of this carbonyl carbon. The hybridization of that carbonyl carbon is sp2. It is what? sp2. But after attacking of water on this carbonyl carbon become sp3 hybridized. sp3 hybridized. Okay. So then what happened? S character decreases. So whenever X character decreases, electronegativity also decreases. In geometry, shape, all those things will be affected. Next, here see, after, so this is second step. What is second step? Attacking of water molecule on carbonyl carbon. So thereby we can get the sp3 hybridized carbon. Okay, so again this is hydronium ion. It will readily lose H plus ion. So thereby we get this one, geminal. Geminal. Why? Because three functional groups presented same carbon. So that carbon is known as geminal. And step 3, what happened again? One more H plus ion is donated to here nitrogen. Here that is one more hydrogen ion is donated to the nitrogen. So thereby again we may get ammonium. This is quaternary ammonium salt or ammonium ion, and it becomes a good leaving group. So readily it will be eliminated. So how? By shifting of lone pair of electrons. So that is fourth step. So once the ammonia is eliminated, what happens? This oxygen got the positive charge. So in fifth step, what happened again? Whatever ammonium ion is eliminated, again that will take up H plus ion. So thereby we get carboxylic acid and ammonium ion. So this ammonium ion is less reactive. Why? Because it doesn't have any free lone pair of electrons. So that's why it cannot attack on this carbonyl carbon, or it do not acts as a nucleophile. It cannot act as a nucleophile. So nucleophilic character is not no more. So it lost nucleophilic character. So this is acidic hydrolysis of amide. So in similar manner, now we have hydrolysis of ester. So similar same process will be, we can expect here also. Uh, okay, so already we have discussed in the preparation of carboxylic acid, both hydrolysis of esters, acidic hydrolysis of ester, and saponification. Saponification is also known as basic hydrolysis of ester. Next, let's see the ammonolysis reaction. So here, ammonolysis. So acid halides or this acid chloride is more reactive. So that's why when it is treated with ammonia, what happens? It readily lose HCl molecule. So this chlorine will go out along with one of the hydrogen of ammonia as HCl, and thereby we get this amide. And this reaction is also known as ammonolysis also. Okay, ammonolysis. So this is the mechanism. In first step, what happens? So I will show you mechanism. Okay, so in first step, what happens? Cl plus NH3. So on nitrogen, we have one lone pair of electron. This lone pair of electron attacks an electrophilic center. So thereby that facilitates the shifting of pi bond on oxygen. So thereby we get this one O minus, here NH H H. So this is plus, and here Cl minus, and here one of H plus ion will be removed, and it will attach it to this hydrogen oxygen, or else it may direct attacks on oxygen also. Okay, let's say I will show you how it is. R so it becomes RNH OH, and this is NH here, this here. So it will shift here and it will be eliminated. So from here H plus is going out, H plus is going out, here Cl minus is going out. So that H plus and the Cl minus both will form what as HCl, and we get our desired one, that is what amide. So this is known as ammonolysis reaction. Again, this is acidic hydrolysis of amide. This is acidic hydrolysis of amide. Again, similar fashion, amides will be hydrolyzed to corresponding carboxylic acid. So if same hydrolysis is carried out in presence of base, then what we get? We get again same product, one and only product. Okay. So this is basic hydrolysis. Here we are using this one. So in that basic hydrolysis, this is the variation. So all these are reversible steps. Here we get only carboxylate ion, and acidic hydrolysis of this carboxylate ion, we get the carboxylic acid. Okay. Next is here, see, same thing. Whatever we discussed here, this is ammonolysis of SL halide, and this is ammonolysis of esters. Same thing. Again, this primary amines acts as a strong nucleophile and it attacks here. So thereby what happens? Facilitating the complete shifting of pi electrons. We get the what we said, two ions, deuterion, plus and minus, and then one more another amine will act as a base and takes up this proton. So thereby we get this one, and next one, this negative charge or lone pair of electron shifts here, and it will be eliminated as OR, and we will get this secondary amide. And next one, preparation of the cyanides, or you can say dehydration. So dehydration, so it is another reaction. Dehydration means removal of water molecule from reactant. So this is hydrolysis. For hydrolysis, we have in lower classes we have studied the hydrolysis with P2O5 or anhydrous calcium chloride or SOCl2 PCl3. All these POCl2 this POCl3 SOCl2 that is already we have studied about SOCl2, as it is a thionyl chloride. It is one of the best chlorinating agent. It is the best chlorinating agent. Okay, so let's see the dehydration. So what is dehydration? Removal of water. So when we remove the water molecule from the amide, what we get? We get a cyanide. Okay, so this reaction can be achieved by using either thionyl chloride or else P2O5 or else POCl3. Okay, so let's see the mechanism, how it happens. So again, see when the nitrogen. So okay, here I'm writing. Okay. So this is amide or C double bond O NH2, and this amide here, see, and lone pair of electrons of nitrogen will be participated in resonance. So thereby we get R O minus, and this is double bond NH2, and here it will get the positive charge. Okay. So there, what happens again? This lone pair of electron here, the carbon and nitrogen. So which is higher, which is more electronegative? Nitrogen is more electronegative. So that one happens. These lone pi electrons are partially migrated towards the nitrogen. So thereby again it becomes more electron deficient. This carbonyl carbon becomes electron deficient. Or else you can say electrophile. Okay. So next one, what happens? This SOCl2. So if you look at the structure of SOCl2, so this is SOCl2, S double bond O. This is Cl. This is Cl, and this sulfur has one vacant orbital. So it will utilize that vacant orbital. So how it will taken up the electrons from? It will taken up the electrons from this oxide. Okay, so what is that? Oxide. So R, so O minus, and this is what? Double bond NH2 plus. So it will donate its electron to this sulfur. So thereby what happens? A bond is formed between uh, NH2 plus, and this is O, and this is sulfur, double bond O, Cl, Cl. Next thing what happens? So here, from here, okay, just I'm expanding those hydrogens. Okay, so this nitrogen is attached to two hydrogens. I'm expanding. So one of hydrogen will be removed. So thereby what we get? We get okay, like this. Next one, what is it? This will be eliminated. Uh, so when this one is attached, this minus negative charge attacks on sulfur, that facilitate the shifting of one of the pi bond of oxygen to an oxygen. Okay, so I'm supposed to write this one as, so this is O minus, and it becomes more electron rich. So again what happens, this negative charge will come here. So again from here one of the Cl minus is removed, from here H plus ion is removed, here from Cl minus, so both will be removed as HCl. So thereby we get R C double bond, uh, sorry, not double bond, double bond. So this is H, and next step is what? S, no, sorry, not S, this is oxygen. This oxygen is attached to the Cl, and this is O. And next step what happens again? So this lone pair of electrons attacks here, then this bond shifted here, so it will be eliminated as Cl minus. So then what happens? We get R C triple bond N, and it will get plus charge here in H. So I will elaborate this. Okay, so here bond H. So here Cl minus, along with we may get one more product, that is SO2. And now this Cl minus will taken up this H plus. So thereby what happens? Removal of HCl, and we get what? Cyanide. So this is the way of formation of cyanides. So this reaction is known as dehydration. And same again, dehydration, instead of SOCl2, if you want to run this mechanism, run reaction with POCl3, that is also known as phosphonyl chloride. So you will get like this. So this is the mechanism. Okay, if you want to carry out dehydration with P2O5 phosphorus pentoxide, so it is the mechanism. So this is about dehydration. Okay, and the mechanism of anhydride hydrolysis. So last one is hydrolysis of anhydride. So when we hydrolyze, again what we get, hydrolysis of any acid derivative will give ultimate product, that is carboxylic acid. So this is the mechanism. Okay, so with this we have completed carboxylic acids and its derivatives. Okay, so after this we will move to the next lesson of organic chemistry. I will provide the material, everything to you. I will keep this material in your Google Classroom, or else if you want, I will forward to your WhatsApp group also. Okay, so thank you.